Red drill the science drill.
Red drill the science drill.
Red drill the science drill.
Welcome to another episode of Red Drill the Science Thrill. Today we're going to talk about ECI, race car chassis, and many types of different analysis we can do on it. Does anybody know a few? Ooh, pick me! Yes, you, the young man in front. What's your name?
Trevor, and they're static, frequency, and torsional.
Very good. Gold star for you.
I want a gold star.
Let's start with the static load test. Here, the mild steel chassis has boundary conditions fixed at the four joints where the wheels are located. Then, a 13.3 Newton per meter load is applied at the bottom of the cockpit. These loads include the weight of a person, engine, chassis, transmission, and the steering system. All these loads are translated into a static load by the force of gravity using standard mesh details. In the stress plot, we resulted in a max of 1.1 megapascal and a 0.0133 millimeter displacement.
How interesting. But what about the torsional analysis, Professor Renteril?
Well, Trevor, I'm glad you brought that up. Here, the driver's front left-hand axle is fixed, along with the two nodes in the back of the engine bay. One spoke is left intentionally undefined by a boundary condition because we want to measure the torsional rigidity of the chassis using standard mesh details. In the stress plot, we resulted in a max of 25.96 megapascal, and in the displacement plot, we resulted in a max of 0.958 millimeters.
So, because torque is a moment force, the torsional rigidity is the measurement of the bend in the chassis?
Correct.
Professor Renteril, is there a way to alter specific parts of the chassis to test how these variables can affect the analyses?
I'm glad you asked, Lauren. The process is actually known as design iteration.
No way!
Here we remove the cross member in the front bulkhead. As you can notice, it is now a hollow square. The boundary condition was fixed at three nodes, two in the back of the engine bay and the front left where the wheels are mounted. The force load, signified as a purple arrow, is 500 newtons on the right end where the wheels are mounted. In the stress plot, we resulted in a max of 28.1 megapascal, and in the displacement plot, we resulted in a max of 1.1 millimeters.
Wow, I learned so much today.
Yeah, thanks, Professor Renteril.
Wow, I finally learned something today.
If you liked today's episode, tune in next week. Bye!